Hello and welcome to another video. I'm going to be doing a quick tutorial on tests for proportion. And this is basically copy pasted straight off the MyLab Math, the Pearson software that Concordia uses. They'll use it in the quiz system that you'll have. I think probably 6. If they're not using MyLab Math, it'll be still identical to whatever problem you'll see in Chapter 9. So let's jump into it. Of a random sample of 207 auditors, 95 indicated some measure of agreement with the statement, cash flow is an important indication of profitability. So we want to do a test at the 10% significance level. It's a two-sided alternative hypothesis, so we're going to be looking at both sides of the distribution. And we want to test the null hypothesis that 1/2 of the members of this population would agree with the statement. So it's a pretty straightforward question. On the left side, I've jotted down all the information straight from the question. So sample size of 207, a proportion of 45.89%. That's the 95 over 207. 95 indicated that they agree. And what we believe to be true, 0.5. That is the P naught, that is the null hypothesis. And so basically what we're doing is we're saying, well, we believe in the total population of auditors, whether it be a firm of auditors, if we're looking at, or maybe the country of all auditors in the world, which would be quite a task. We're saying that we've taken a sample of these auditors, and we found that 45.89% of them agree with this statement. Now we want to see how likely, given the population size, how likely is it that this statistic is within the realm of probability, that 0.5, or is it so different than what we're expecting that it leads us to believe that 0.5 is not an accurate. Maybe we're wrong. Maybe we shouldn't be thinking that 0.5, that 50% of auditors agree with that statement. So really easy. We on the right side we have our proportion formula, and it's just a simple plug and play. You'll enter in all the information that we see jotted down, and we'll get a negative 1.18 z statistic. Always z statistics per proportions, unlike test for the mean. There's no sigma known, there's no sigma unknown. It's always going to be z. And so now we want to find out what kind of test we're going to do, what kind of case this is. So as in the previous video, we have 3 cases. One where it is less than negative ZA, and there's a couple ways to find this out without being told right away that it's a two-sided alternative. I mean, the second part also says that 1/2 is 1/2. It can either be is 1/2 or is not 1/2. If it was at most 1/2, we're only testing the left half, the lower side, right? At most, it can only be less. It is either less than or equal to, or it's going to be more. Sorry, it can be tested the right side. Or in the other case, it'll be at least, so it'll be greater than or equal to, in which case we'll be testing the left side. Because the alternative will be that it's not greater or it's not greater than or equal to, it'll be less than. So you'll only be picking one side. But if it is or is not, it is either equal to the null or not equal to the null. Thus, we are having to look at both sides of the normal distribution. So we're going to take our 10% and split it between both sides, creating 2 rejection regions, depending on where our z statistic lies. And you can see right away that it's already marked down in the middle. To find the z-stat, you can look at your z-tables. You subtract the significance, 0.05, from 1, that 1 being 100% of the area under the curve, and then the 5% obviously being on both sides. And it'll give us and you'll find that, which will be 0.95, and on the table it's smack in the middle between 1.64 and 1.65, so we've just taken a value that's smack in between them. So on the bottom left, we have negative 1.645 and 1.645 on the right. These determine the boundaries of our distribution and then set the rejection zone, the rejection areas, as you can see. And as obviously, this is a pretty simple question. We can see that our z statistic falls in the middle, which means that the probability of obtaining this statistic while the 0.5 being true is not unreasonable. It's not enough to say that maybe we should evaluate what we believe for our population proportion to be, and then reject that null, and look for an alternative that it is not 0.5. In fact, it may be something else where this z statistic would fall within this, because the probability of obtaining a statistic, in those rejection regions is pretty unlikely, which is the whole point of the test. So in this case, we would not reject the null, as you can see, because it lies between outside of the rejection regions. And now we want to find a quick p-value of the test. A p-value is the probability of obtaining, first of all, it's the probability of obtaining that statistic, and it's the probability of obtaining, not that statistic specifically, a probability of obtaining a statistic more extreme than the value you got. So when a p-value is greater than your significance level, you do not reject the null hypothesis, and it works the same way, basically. You can see how if the probability is bigger than alpha, then of course the whole rejection region is bigger than alpha completely encompassed. It has alpha, it completely encompasses the alpha region and more. So we, that's enough evidence to say, well, this could have happened in alpha or outside of alpha, which means, this would not lead us to indicate that we should, be thinking for another true proportion. When you have a two-sided alternative hypothesis, however, we have to double the p-value because we have to account for both sides of the distribution. The same way we have to put both boundaries when we're doing a two-sided test. So yeah, that's basically it. It's a pretty simple question, and they'll stay like that through most of the chapter.